Our aim today is 9.11, frequency and period of sinusoidal functions. So, can you spot the difference? The red graph completes one cycle by 2 pi, while the blue graph completes 2 cycles in that same time period. This is known as the frequency. The frequency of a trigonometric function is the number of cycles it completes in a given interval. In this case, we'll be examining it from 2 pi. So the period of a function is the horizontal length of one complete cycle. Frequency and period. So if we go back to our blue graph, the frequency was 2 because we completed 2 cycles by 2 pi, but the period was pi, in that at pi, one cycle had been completed. You can also think of this as 2 pi divided by 2 for the number of cycles is equal to pi. So amplitude, frequency, and period of sinusoidal functions. This is the standard form in which we write sinusoidal functions. Notice how cosine is listed as a sinusoidal function. If you noticed, especially in our past lesson, that the sine and cosine curves are identical, the only difference is that there are horizontal shifts of them. And also, if you notice in the unit circle that they have a lot of the same values. And that's because they're co-functions, meaning that they're the same function, except there's some horizontal shifting. So one is off a little later, or one starts its process or its curve a little later than the other. So the amplitude is the absolute value of A. If A is negative, that flips the graph, but it does not change the amplitude, and it flips it along the x-axis. The frequency is represented by B, and you can determine that by 2 pi divided by the period. And the period is 2 pi divided by B, which is the frequency. So the horizontal shift is C. And of note, just like any other horizontal shift, when you're subtracting, when it's a subtraction of a number, so for example, x minus 5, that would be a shift 5 in the right direction or 5 in the positive direction. However, if it was x plus 5, that would be 5 to the left. So you're going in the opposite direction of the sign listed. And for D, it represents the vertical shifts up and down. And if it's positive, it moves up. If it's negative, it moves down. So here is a pictorial representation of that. The only thing is for amplitude, it's the absolute value of A, not just simply A. So what is the frequency and period here? Well, if you'll notice, it takes 6 pi to complete one cycle. Therefore, the period is 6 pi. So what is the frequency? Well, the frequency is how much has been completed by 2 pi. So if you take 2 pi divided by 6 pi, that's 1/3. Therefore, your frequency is 1/3. At 2 pi, only 1/3 of the cycle has been completed. Let's try another one. So imagine if you could sketch the rest of this. How much would be completed by 2 pi, and at what x value would the cycle be completed? So here we're seeing just a portion of it at 2 pi. Let's extend this graph to see when one cycle would be completed. So here, if we were to double that, our arch would go back down to 0 at 4 pi. But because this is not a complete cycle, because we know there's a dip, especially for sine graphs, it would continue to fall at its minimum. It would hit its minimum at 6 pi and rise again at 8 pi. Therefore, the period is 8 pi, while the frequency is 1/4, because 2 pi divided by 8 pi is 1/4. Notice how a quarter of it is completed by 2 pi. So what is the equation of this graph? Well, if you'll notice a few things here. Notice how it doesn't start at the origin. So how do we determine what this could be? Well, I gave you two different ones, so I'll talk through this one first. So notice that the midline is 1, and its period is 3 pi. This here would be a sine graph. Why would this be a sine graph? Well, a sine graph originates at the origin, but notice it's also flipped down. Sine and cosine rise first in the first quadrant before going negative. So here, this would be negative. It would start off as a negative, but a negative sine function. And what would be the amplitude? Well, if the midline is at 1, is that the line y is equal to 1, and it has a height at 5, the amplitude is 4. But notice how it's flipped down. So this would be y is equal to negative 4 sine of, how can we determine what the frequency is? Well, the frequency is 2 pi divided by the period. Notice that the period is 3 pi. So 2 pi divided by 3 pi is 2/3. So our full equation here would be y is equal to negative 4 sine 2/3 x plus 1. And now let's look at this from a perspective of cosine. Let's try one with cosine. So what's the midline? Well, the midline is y is equal to 1. And what is the parent function? The parent function is cosine. If you'll notice for the unit circle at cosine, at 0 degrees, your cosine at 0 is 1. So cosine starts high and then it goes lower, while sine continues to stay high before dipping in the third quadrant. And I mentioned this before, that sine and cosine graphs are cofunctions, and so that's why they look alike. They're just shifted horizontal shifts of each other. So what would be the amplitude? Well, the amplitude here is 4. And what is the frequency? Well, if we have a period that's 3 pi, the frequency would be 2 pi divided by 3 pi, which is 2/3. And again, notice that this is negative, so it's flipped down. Therefore, our answer here would be y is equal to negative 4 cosine 2/3 x plus 1. Or if you were to think about this in terms of sine, because cofunctions are just off by 90 degrees or by pi over 2, you could simply add pi over 2 here, and you would get the exact same function, both with respect to sine. Your homework today is delta math, and you have SPR for determining the period of a function.